Hello, this is Solving Systems of Equations by Elimination. This is lesson 8.3, and we will be covering pages 243 to 250. I'm also going to be doing some of the homework problems today, so you're going to want to get your book and have that ready. I'll see you in a moment. Okay, I want to talk about the standard that we will be in today. We will be in standard, little thing made a decided to make a glitch here. We are going to be in standard EE8. I can solve systems of two linear equations and two variables algebraically using elimination. So again, to pages 247 to 250. So let's talk for a few minutes. Here's some notes I'll share with you. So there are different methods for solving systems of linear equations. And we know that systems of linear equations are going to have a solution of a point, an x-coordinate and a y-coordinate point. So the first method we used for solving linear equations was the graphing method. So I wanted to just review that for a minute so we can figure out the different methods we have. So the graphing method is to put the equations into slope-intercept form and then to graph them on an actual graph, coordinate plane graph, and find the point of intersection. The advantage of this is that you can visually see that point of intersection. So if you have integer whole numbers, it works out pretty well. The disadvantages is you're not always going to be accurate, especially if you don't have an intersecting point that's an integer or a whole number. So then you're going to end up with some fractional part, and you're not exactly sure what that point is. So that method does not work really well when you start dealing with rational numbers and fractions and that. So the second method we talked about in our last lesson was the substitution method. So that's where you manipulate one of the equations to get it into slope-intercept form, into the y equals mx plus b format, and then you plug in what y equals into the other equation for y. And then you have to use a whole lot of algebra to solve it, and then you get the solution to one of the variables. It would be the solution to the y variable, no, the x variable probably, and then you would substitute the value you get for the x into one of the two equations and get the y value. So the substitution method's advantage is if one equation is already in slope-intercept format, it's pretty quick to just substitute in the expression for what y equals into the other equation. The disadvantage is it can be really messy when you're dealing with fractions. It also uses a ton of algebra. So if you felt kind of overwhelmed on the last lesson because of using the substitution method, today I think you're going to be like, oh, this is so much better. So the substitution method can be messy and it's really easy to make mistakes. So the method we're going to learn today is actually my favorite method. This is called the elimination method. And what you're going to be doing is eliminating one of the variables by adding the two equations together. Sometimes you have to multiply by another number, a negative or a positive number, to get to that elimination step, but we'll show you that today. But overall, it's a very much easier method to use when solving systems of linear equations. In your book, they actually do adding equations and subtracting equations. I'm just going to do the adding because the subtracting is actually a lot more confusing and can lead students to many errors. So I am not going to be showing you the subtraction method, and you will never really need to use the subtraction method. You can use any one of the three that I've shown you to solve these systems of linear equations. And my guess is that you're going to enjoy this method the most. So the advantage is this method is the quickest for solving these systems of equations, and it gives you the least amount of algebra that you have to do, and you don't have to rearrange equations like you had to in the other two methods. The disadvantage is you need to be very careful with your negatives and your positives when you're multiplying and when you're adding and subtracting, which you have to do with the other two methods anyways. So it's really not a disadvantage in the sense that you still have to be careful with any of the methods with your subtracting and you're multiplying and you're dividing with negatives and positives. Okay, so with that said, I'm going to start on page 244, and I'm going to go under the document camera. So go ahead and turn to page 244, and I'll see you in a moment. Okay, this is number 3, the Your Turn problem on page 244. Here we have a system of equations, and we are going to use the elimination method, and I'm going to put that up here, elimination method to solve this system of equations. So you'll see that I have 2, and if you notice, what I'm going to be doing is I'm going to draw a line under these, and I'm going to actually add these equations together. So when I add, I have x, so pretend there's a 1 in front of there, because there's an imaginary 1. 1x plus 1x. Yes, that would be 2x. I'm going to add we'll put a 1 in front of there again, just so you can see that. I have a 1y plus a negative 1y. It's adding a negative 1y. So if I have a positive 1y and I add a negative 1y, I'm going to end up with, right, 0y equals, now I'm going to add negative 1 plus 7. You owe me $1. You have $7 in your pocket. You pay me what you owe me. What do you have left? Exactly, you have $6 left, or 6. Then we can drop the 0y, and we're left with 2x equaling 6. Now we're going to solve by dividing both sides by 2. And by now, this should be something that you're getting pretty good at. I'm going to cross off my 2's, because those just equal 1. And I'm left with x equals 6 divided by 2, which is 3. Okay, that's going to be our x coordinate. We'll put it up here. We don't know the y yet, so this is our x coordinate. So to figure out y, what do you think we have to do? Exactly, we have to plug back in the x into one of the equations above. It does not matter which one. I'm going to plug my 3 in for that x. You could easily just put it in for the other one on the top. It doesn't matter. So if I plug that back in, try to keep this all on the same screen, I get 3 minus y equals 7. Because I plugged in my x, I plugged a 3 in there because that's what x equals. Now I just solve for y. I subtract 3 from both sides. 3 minus 3 is 0, minus y. 7 minus 3 is 4. And then I am left with negative y equals 4. That's really a negative 1y, right? So I'm going to multiply by, or in this case divide by, a negative 1 to both sides. That crosses off my 1's. My blue pen back. Crosses off my 1's. And I'm left with just y equals 4 divided by negative 1 is negative 4. So if I go back up to the top, the answer then is 3, and my y value is negative 4. If I'm not sure if I did that correctly, I can check it. So let's go ahead and remember how we check. So if we're going to check it, we're going to plug 3, negative 4 into both equations to see if it yields a true statement. So our first equation was x plus y equals negative 1. Plug in 3 for x plus negative 4 for y. That should equal negative 1. 3 plus negative 4 is negative 1. So negative 1 equals negative 1. So that is true. Let's check the other equation. That equation was x minus y equals 7. So we plug in 3 for x. We plug in, be careful on this, a negative 4. I'm going to put it in parentheses. This over just a little bit. Equals 7. So this is 3 minus a negative 4. So whenever we minus a negative, it really becomes 3 plus 4 equals 7. Does 3 plus 4 equal 7? Yes, 7 equals 7. So that also is a true statement. So that means that 3 negative 4 is a solution to both the first equation and the second equation. This is the point of intersection if we were to graph this. So that point is on both lines. So we did do it correctly. We have the correct answer. Now I'm going to go on and do the guided practice, page 248. So pause the video and turn to that page. Okay, this is guided practice, page 248. Here is our system of equations, and we want to use the, what method are we using? The elimination method. We are using the adding elimination method because that one is the best one that will keep us from getting confused. So we were going to add our two equations together. So we're going to add 4x plus x, or put a 1 in front of it if it helps you. 4x plus 1x is really 5x plus 3y plus a negative 3y, exactly 0y, equals 1 plus negative 11. Don't get mixed up on this. Negative 11 is how much you owe me. You pay me the $1 you have in your pocket. How much are you still going to owe me? Exactly. You still owe me $10. Okay, now we're going to drop the 0y. 5x equals negative 10. I have to divide by the coefficient of 5 to both sides. The two 5s are going to cross off. And I'll be left with x equals negative 10 divided by 5 is going to be a negative divided by a positive will give me exactly a negative 2. Okay, then I'm going to take my negative 2 and I'm going to plug it back in for x in one of these two equations. I'm going to pick to me what looks like the simpler equation. So I'm going to take this negative 2 and I'm going to plug it in for x in the second equation, because to me that looks a little simpler. So let's do that. So instead of x minus 3y equals negative 11, we are going to have negative 2 minus 3y equals negative 11. I just plugged negative 2 in for the x. And now I'm going to solve for y. So I know that I have to add 2 to both sides. Negative 2 plus a positive 2 will become a 0. And I'm left with negative 3y equals negative 11. You owe me $11, but you pay me 2 of the dollars. You still owe me 9, right? Negative 9. You're still in the hole, $9. Drop the 0. You're left with negative 3y equals negative 9. Divide both sides by negative 3. Don't forget it's a negative 3 to both sides. The negatives will cancel each other out, and the 3's will cancel. You're left with just a y equals a negative 9 divided by a negative 3. Two negatives divided by each other makes a positive, yes, a positive 3. So the solution to our system of equations is x is negative 2, y is 3. Here's my x, here's my y. That is the solution to the problem, number 1. Now, if you wanted to check it to make sure you did all your algebra and your minuses and your pluses correctly, you could plug -2 and 3 into both equations up here for the x value and the y value and see if you get two true statements. If you do, then you know that you have solved the system of equations and you have a point of intersection that is on both lines. We're not going to, in this video, for the purposes of time, be able to check all of our answers, but I just wanted you to know you can always check your answers, and it's a good idea, especially when you get into higher math, to be doing that. So now the next one I'm going to do on guided practice page is number 3. I'm skipping some of them just for the sake of time, but I still want you to complete them for homework and turn them in. So this is guided practice page 248, number 3. We have our system of equations. We're going to use the elimination method of adding the two equations together. Okay, so we're going to draw our line like that. Do you see a problem? Have you figured out where the problem is? If I add these two, I get 6x. If I add these two, I get -1y. I have to eliminate, elimination method, one of the variables, correct? So I can't really do it the way it is. So here's what you do when you have this situation. You are going to multiply one of the equations by a number. So in our case, I'm going to pick the second equation, and I'm going to multiply by a -1 to both sides. Remember, whatever you do to one side, you have to do to the other side. So my top equation is still going to be the same. I'm not doing anything to that one. 3x plus y equals 23. But now look what happens when I multiply a -1 by the entire equation. -1 has to be multiplied by each number in the equation. So -1 times 3x is a -3x. Be careful on the next one. -1 times the -2y. Two negatives multiplied together will give you a positive. So that's going to become plus 2y. And then on this side, we have a -1 times 8. A negative times a positive is going to give me a -8. Okay, and now I can do my adding of my equations. I have not really changed this equation in any way other than multiplying each number by -1. So it's the same equation because I've kept everything the same. I've balanced it with multiplying every number by the -1. So now let's do this. 3x plus a -3x is going to give me 0x. A y, and remember that's the same as 1y. 1y plus 2y is exactly 3y equals 28 or 23 minus 8. Exactly 15. I can drop the 0x and I'm left with 3y equals 15. Exactly, I divide by 3. The 3's will cross off. I'm left with y equals 15 divided by 3, or 5. I have my y value now. Last time we had our x value. It doesn't matter as long as you eliminate one of the variables. And we did. This time we eliminated the x. On the last problem, go back to it for a minute, we eliminated the y values. It does not matter if you eliminate the x's or the y's. I just eliminated x because I had a 3 in front of both of them. So now I'm going to plug my y value of 5 back into one of these two equations for y. I'm going to pick the easier equation. I think this one's a little bit easier because I don't have to multiply like I do here with a negative. So I'm going to take this 5. I'm going to plug it in for y right there. So I'm going to end up with my new equation of 3x plus, what's my y value? 5 equals 23. So now I'm going to solve for x. I'm going to subtract 5 from both sides. This will become 0. I'll be left with 3x plus 0 equals 23 minus 5. 22, 21, 20, 19, 18, positive 18. I'm going to drop the 0 and get 3x equals 18. I'm going to divide both sides by 3. The 3's are going to cancel out. And I'll be left with x equals 18 divided by 3, 6. I now have my x coordinate and my y coordinate. The answer then is 6, 5. Be careful that you put it in the right order. 6 is the x, 5 is the y. Be careful that you don't switch that around because remember we solved for y first on this one. That is the solution to our system of equations up here. If I plug 6 and 5 in for x and y to both equations, it should yield a true statement, and I can check that by doing that if I would like to. Okay, this one is number 5 on page 248, guided practice. You're going to want to be writing these down because you're going to be turning this in for me. I'm going to add, I'm using the elimination method, adding the two equations. So I see that I don't have to multiply by a -1 on this one because I already have a negative and a positive 2y, so that will work out real nice for me. So I can just add, and I'm going to put a 1 in front of here. So 1x plus 5x is going to give me 6x. My -2y and my positive 2y are going to cancel out and become a 0, so I'm just going to eliminate that step. So 6x is now going to equal -19 plus 1. You owe me $19, but you pay me the $1 you have in your pocket. Exactly, you now owe me -$18. That's how much you're in the hole. You're going to divide both sides by 6. You're going to cross off your 6's. You're going to be left with x equals a -18 divided by 6 is going to give you a -3. That is our x value. We are then going to take that x value and plug it back into one of these two equations. Pick the easier one. I think -3 getting put back into this equation is a little easier because I don't have to multiply by a 5. So I'm going to plug that in, and now I'm going to have -3 minus 2y equals -19. Solving for y, I'm going to add 3 to both sides. That'll give me a 0. These will cross off. And now I have left -2y equals, be careful on this, you owe me $19, -19. You pay me the $3 you have in your pocket. You're still going to owe me how much? -16, correct. Divide both sides by -2. The -2's will cross off. I'll be left with y equals -16 divided by -2. A negative divided by a negative is going to give me a positive 8. Yes. So I have my x value, I have my y value. The solution to this system of equations is -3, 8. My x value, my y value. I can plug that back into the original equations up here, the x and the y value, and I should yield 2 true statements if I did it correctly. Okay, this is number 7. hopefully you're getting the idea of how to do this. We're going to add, we're using the elimination method to get rid of one of the variables, either the x or the y. We have a problem on this one. If I add a -5 and another -5, I get a -10. If I add 7 plus 3, I get 10. I'm not eliminating a variable. I have to get one of these coefficients to 0. So what I'm going to do is multiply one of these equations by a -1. So I see that these are both 5s. So I'm going to multiply the first equation. Let's do the second. You can do either one. The second equation by a -1. I'm putting parentheses around the whole thing because I'm going to multiply the whole thing by a -1. I'm going to multiply -1 times -5x. I'm going to multiply -1 times 3y. And I'm going to multiply -1 times 19. Each one of the numbers. So I can leave my first equation the same. I'm going to have to scrunch this in a little bit. -5x plus 7y equals 11. That stays the same, doing nothing different to that one. But now on this equation, let's see what happens. -1 times the -5x. That's right, it's going to be a positive 5x. -1 times 3y. That's going to be a negative 3y. And a -1 times 19. That's going to be a negative 19. Then I'm going to be able to now add these and eliminate one of the variables. So -5x plus a positive 5x, that's going to produce my 0x. So I basically have just eliminated that, and I'm left with just the y's. I have a 7y plus a -3y. Positive 4y is equal to 11 plus a -19. So I owe $19, but I pay 11 of that debt. How much more do I still owe? Exactly, -8, right? Now, what am I going to do? We're going to get rid of the 0x and have 4y equals -8. Divide by 4 to both sides. The 4's will cross off, and I'll be left with y equals -8 divided by 4 is going to give me a -2. So in our case, we solved for y first. We are going to then take the y value and plug it back into one of these equations. In this case, it doesn't really matter. They're both about the same in difficulty. I'm just going to pick it right here and put it in for that. So now that will give me -5x plus 3 times the y value is -2. That gets plugged in for this. Equals 19. And then I'm going to do -5x. Careful on this one. It's a positive 3 times the -2 plus -6 equals 19. Now I'm going to solve for x. I'm going to add 6 to both sides. That eliminates the 6's. I'm left with just a -5x equals 19 plus 6, 15, carry the 1, 25. Last step, I'm going to divide by -5. Be careful, you're dividing by a negative. -5. That's going to eliminate the 5's. You are now going to be left with an x equals 25 divided by -5 will give you a positive divided by a negative will give you a negative answer of 5. So now you have your x and your y value that makes the equation true for both. So our answer then is, be careful, -5 is the x, that comes first. -2 is the y, that comes second. So the answer is that. If you plug those x and y value back into the original equations, you should get a true statement for both. That's your check. Okay, I want to do some word problems now. So hang in there. This is a little bit of a longer lesson, but I think you'll be glad that I went through these problems with you. So number 8 is the word problem on page 248, guided practice. I wrote it out here for you. And get the whole thing on there. So let's read it together. The Green River Freeway has a minimum and a maximum speed limit. Tony drove for 2 hours at the minimum speed limit and 3.5 hours at the maximum limit, a distance of 355 miles. That sounds like an equation waiting to happen, right? Okay. The second equation, I'm also going to underline or circle Tony here because that's the first guy. The second equation is going to be Ray. Ray drove 2 hours at the minimum speed limit and 3 hours at the maximum speed limit, a distance of 320 miles. The question is asking us, what are the two speed limits? Okay, this is a system of equations because I have an equation for Tony, I have an equation for Ray, and I'm going to find their point of intersection. So let's set up an equation for Tony. Since I used pink, let's put Tony in pink. So Tony's equation. What's Tony's equation going to be? Well, first of all, let's decide what our variables are going to equal. Let x equal minimum speed limit, and let y equal, what do you think? Maximum speed limit. Got to make sure we know what our x and our y stand for when we do these word problems. Okay, so for Tony, we're going to say he drives for 2 hours at the minimum speed limit. 2 hours times the speed limit, whatever the number turns out to be, plus he drives 3.5 hours at the maximum speed limit. 3.5 hours times that speed limit, y, and he drove a total of altogether 355 miles. That's our first equation. Now we're going to do Ray. Since I started her in green, we're going to make her green. So for Ray, she drove 2 hours at the minimum speed, 2 hours at the minimum speed x, and 3 hours at the maximum speed, plus 3y equals a total distance of 320 miles. Now we have our system of equations. Here is our system of equations that we're ready to solve. Okay, now we are ready to solve. So number 8A said, let me get to that page. It said A was write the equations to represent Tony's distance and Ray's distance, and we did that. That's Tony, that's Ray. B is solve the system. So that's what we're going to do now. So we're going to solve the system. So what are we going to do? We're going to use elimination. It's the best and easiest and quickest way. We are to add these together, but if you notice, we have a problem. 2x plus 2x is going to give us 4x. 3.5 and 3 is going to give us 6.5. We're not eliminating any x or y, so we have to eliminate something. Since they're both 2's, I'm going to eliminate one of these. So I'm going to multiply a -1, use orange this time, -1 times the second equation, negative 1 times everything in that equation. So it's going to be negative 1 times 2x. It's going to be negative 1 times 3y and negative 1 times 320. I have to do that. So I'm going to leave the first equation the way it was. I'm going to just, I don't have enough room on the right side, so I'm just going to come down here. Down now. 2x plus 3.5y equals 355. That's staying the same. Nothing's changing. The second one, however, is going to change. Negative 1 times 2x is going to give me negative 2x. Negative 1 times 3y is going to give me a negative 3y equals 320 times negative 1, negative 320. Okay, I just rewrote the second equation, so now I can eliminate a variable. Which variable will get eliminated from this method? In our case now, the x, right? 2x plus negative 2x will turn to a 0x. 3.5 plus, is that a negative 3? Yep, that's a negative. It's hard to see that. Make sure you can see that. 3.5y plus a negative 3y. What is that going to give me? That's going to give me plus 0.5y, right? Equals 355 minus 320, or 355 plus a negative 320. 5, 2, 25, right? Positive, yep. Drop the 0, we'll get 0.5y equals 25. And we got to divide by 0.5 to both sides. Not 0.5, 0.5. 0.5 or 0.5. That's supposed to be a point. So these will cross off. And I'll be left with just y equals 25 divided by 0.5 is 55, right? You want to do that, and just to figure it out, use your calculator. You can do this. Move it over 1, 250, 5 times 5 is 25. Oh, maybe 50. Could be 50. Did I make any mistakes? Nope, should be right. Okay, I see my mistake. 5 minus 2 isn't 2. 5 minus 2 is 3. So this becomes 35. So it's 35 divided by 0.5. Always good to check and question yourself. So 5 times 7 is 35. Subtract, bring down the 0, 70. So y is equal to, not 55, y is equal to 70 miles per hour. Now I'm running out of space. I'm going to grab an extra piece of paper back here to do the second part of it. So that means y is our, let's go back up and take a look. What did y represent? Our maximum speed limit. So our maximum speed limit is now figured out at 70 miles per hour. So we can put that as maximum. 70 is our maximum speed limit, miles per hour. Keep that circled. So now this is a good one. Had I not noticed my mistake, I would go back and check it. I would notice that I didn't get it correct, right? So that's why the checking is important. So let's put this paper here now. We'll come back to this here in a minute. We got to plug this all back in. Let's see if we can get some of this up. Yeah, okay. So now I've got to plug in my 70 back into one of these equations. So actually we can take it right all the way up to the top in one of these equations. So I'm going to pick, it doesn't matter, they're both kind of hard. So let's pick y, put y in for this one. Okay. So I have 2, oops, I want to use blue. I have 2x, no, you can't see that. 2x plus 3y, so plus 3 times y, which we're going to call 70, equals, up to the top, 320. 320. Solve now for x. Multiply first, order of operations. 2x plus 3 times 70, 210, equals 320. Subtract 210 from both sides. These cross off and become zeros. I'm left with 2x equals 320 minus 210. That seems like too high of a number, but not really, because we still got to divide by 2. It'll probably work out just fine. X is equal to 110 divided by 2, exactly 55 miles per hour. That is our minimum speed. Right there. So we have answered our word problem. We're both showing it once here. Our maximum speed is 70 miles per hour. Our minimum speed is 55 miles per hour. And I believe that was part B. Yep. So they wanted to know the minimum and the maximum speed. Okay, now I'm going to be switching over to page 250, number 16. Hang in there, we'll be done shortly. 250, number 16. I hope I didn't say number 60. Number 16. Okay, this question is asking us, let me pull it up. It says, is it possible to solve the system 3x minus 2y equals 10 and x plus 2y equals 6 by using substitution? If so, explain how. Which method, substitution or elimination, is more efficient and why? So this is one of these problems I wanted to do with you because I wanted to show you, and you are going to have to turn this in, so you're going to want to copy this down. I wanted to show you why elimination is the best method for solving systems of equations. So we're going to try the substitution method. That's the last lesson. So let's do that first. So in order to do that, we need to get one of the variables by itself. In our case, we could do y equals mx plus b, but then I'm going to end up with a little bit of extra work because I have to get rid of my 2. So I'm going to just have it be the x equaling something, okay? So I'm going to rewrite that as minus 2y to both sides. That would give us x equals, because these are going to cross off, 6 minus 2y. Okay? Now I'm going to substitute this x value here, this expression, into the other equation. You can't substitute it back into the original. You can't substitute it into this one. That's a mistake, okay? Don't do that. So we're going to plug this value in for the other equation. So let's rewrite this now. 3 times whatever x's expression is, I'll just put that in pink. It's 6 minus 2y. That whole thing is getting put in for x. Okay? Minus 2y equals 10. So now I have to use the distributive property first to multiply the 3 times each number in the parentheses. 3 times 6 is 18, minus 2 times 3 is negative 6y, minus 2y equals 10. I can combine my negative 6y and my negative 2y, which is really negative 8y. So I have 18 minus 8y equals 10. And now I'm going to get the y by itself, so I'm going to subtract 18 from both sides. When I do that, My 18 and my negative 18 cross off, and I'm left with just negative 8y equals negative 8, because positive 10, negative 18 will leave me with a negative 8. I'm going to divide both sides by negative 8. Hang in there, guys. Don't fall asleep here. Negative 8 divided by negative 8 is y equals negative 8 divided by negative 8 is going to give me a positive 1, right? That's my y value. Now I have to substitute my 1 back into one of the original equations from the top up here. So I'm going to substitute my y in for this value right here. So I'm going to draw a line. My 1 is going to come all the way up, and I'll keep showing you as it goes, to be plugged in for that. Okay? I know it's 1, and I'm going to plug that in. So that is going to be, where can I do this? I'll do it on the side here. X plus 2 times 1, that's my y, equals 6. Okay? So x plus 2 equals 6. Subtract 2 from both sides. X is equal to 4. So my system of equations answer then is the x value is 4, the y value is 1, x and y. That's the answer using substitution. If we use elimination, are we going to get that same answer? That's what the question is pretty much asking you. So let's go up now and use elimination. Just kind of leave it like this. So elimination. I'm going to add the two equations together and get rid of one of the variables. I see which variable I can get rid of right away. They both have a 2 in the front, don't they? One's negative and one's positive. So I'm going to just add 3x plus x. It's going to give me 4x. The negative 2 and the positive 2 are going to cancel each other out and become 0. Equals 10 plus 6 is 16. Divide by 4 to both sides. The 4 is crossed off. I'm left with x equals 16 divided by 4 is 4. There's my x value. Now I'm going to substitute my x value into one of the original equations. This one is the easier one. I'm going to plug it in for that. So I'm going to plug in 4 for x plus my 2y equals 6. We're going to solve for y now by subtracting a 4 from both sides. I now have 2y equals 6 minus 4, 2. Divide by 2. I now am left with y equals 1. So my answer using elimination comes to x is 4, y is 1. X and y. Now if I look at my two methods, did I get the same answer with both methods? Absolutely. Which method took me less time? Elimination. So just like I said when I started the video, elimination is going to be less steps and way easier to do than this substitution method. So when you can, use elimination. Okay? All right, now I'm going to go back to page 249. We're going to take a look at your homework. I'm not going to go through all of the problems, but I want to give you some hints and some helps. So go ahead and pause and get back to page 249. Okay, here I am on page 249, and I wanted to give you some helpful hints. These are kind of difficult problems to do, but hang in there. You guys are doing really, really well with some really difficult, technically hard math. This is what you're going to get in high school. So this is difficult. So let's look at, I'm going to give you some hints for some of the even problems. So your homework's going to be doing the rest of the guided practice that I didn't do on this video. That's page 248. And then you're going to finish page 249. And yes, I would like you to do the hot problems on page 250 as well. There's only a few, and I'm giving you a lot of hints right here now. So let's look at number 10. So here are your hints for number 10. Let's read it first. Marta bought new fish for her home aquarium. I want to make sure that I'm recording, that I didn't forget to record. Yes. She bought 3 guppies and 2 platies for a total of $13.95. So there's my first equation. Hank also bought guppies and platies for his aquarium. He bought 3 guppies and 4 platies for a total of $18.33. Find the price of a guppy and the price of a platy. So I'm going to set this up for you. So we're going to let x equal, what do you think? I'm lagging a little bit. Yep, we're going to let x equal the guppies price. Okay. We're going to let y equal the platies price. Okay. Now we're going to set up equations. Marta's equation. And then we have Hank's equation. So let's see what Marta's equation is going to be. Let's go back and grab our tool here. Marta bought a new fish for her home aquarium. She bought 3 guppies and 2 platies. Okay. So Marta's 3 guppies times however much they cost, x, right? Plus her 2 platies times however much they cost, y, is equal to, she spent a total of $13.95. Okay, let's do Hank. Hank bought 3 guppies, so 3 guppies, the back one, I wanted to line up, 3 guppies times the cost for the guppies, or the price of the guppies, plus how many of the platies did he buy? 4 platies times the cost of the platies, and he spent a total of $18.33. So you now have your system of equations right here. You're going to be solving this. And notice how you're going to have to multiply -1 times one of these equations. You want to get rid of the 3x. One of these has to become a -3x. You're going to have to multiply by a -1 to one of those equations. That's number 10. Number 11, I'm going to let you do on your own with no hints. So let's go on to number 12. Number 12, let's read it. This one's a toughie, I'll tell you. It says line M passes through the points 6, 1 and 2, -3. Line N passes through the points 2, 3 and 5, -6. Find the point of intersection of these lines. Okay, so remember how we find slope is equal to y2 minus y1 all over, you said it, I'm sure you said it by now, x2, I didn't want it to make a line, minus x1. Right? Exactly. So that's how we find our slope. They're giving us 2 points for each line. So we're going to go to line M, and we are going to find the slope of line M. We are given 0.61 and 0.2, -3. So when we plug that in, y2 can be either one of these. So we're going to pick -3 minus y1 minus 1 divided by x2 minus x1. So let's put that in there. So we have -3 minus 1, and then on the bottom we have 2 minus 6. Be careful that you match the -3 on the top with the 2 on the bottom, because that's its partner, and the -1 or the 1, positive 1, has to be matched with its partner of 6. So then that equals negative, I'll put the line under there, that equals negative 3 minus 1, or negative 3 plus negative 1, negative 4. And on the bottom, that becomes 2 minus 6, negative 4. Put a line there to show that we're dividing. Negative 4 divided by negative 4 is then going to equal a positive 1. That is equal to the slope. Oops, we're running out of room. So go down 1. So the slope of m is equal to 1. We're not done yet. We have to get the equation, right? In order to solve a system of equations, we need the equation. So now we have to go back a couple of units back when we were in school, and we have to figure out how to find the equation. Y equals mx plus b. So we now know m. M is the slope. It's also the slope of the line m, but we can plug that in. So we're going to put 1 in for m here. And now what do we do with the x and the y? Can we put a value in for that? Exactly. We can pick one of these points and plug it in for x and y. I'm going to pick 6 and 1. This is my x value. This is my y value. So if I plug that in, my x value is now going to be 6. And my y value up here is now going to be 1. So 1 is going to equal, let's try to move it so they line up with our letters, plus b. We don't know what b is, so now we're going to solve for b. So we have 1 equals 1 times 6, 6 plus b. We're going to subtract 6 from both sides, and that'll just leave us with b, right? So we're going to subtract 6, oops, wrong line. Subtract 6 from both sides. That will leave us with 1 minus 6, negative 5, and that equals, the 6 and the negative 6 cross off, and I'm left with b. So b is equal to negative 5. So I can plug that back into my equation. So my equation for line m, equation for line m is y equals 1x, you can drop the 1 if you want, minus 5, or plus negative 5, because our b, we just figured it out, was negative 5. So that's the equation for line m. You then need to find the equation for line m using the same method I just showed you, finding the slope, plugging in the slope plus one of the points on the line n, and then solving for b and making your equation. So once you get the equation for line n, then you'll be able to solve your system of equations for the point of intersection. Okay, that one was a little bit of a toughie. Number 14, not going to give you hints for 13. Number 14, I'm going to give you some hints for. So number 14, let's move up. A sales manager noticed that the number of units sold for 2 t-shirt styles, style A and style B, was the same during June and July. In June, total sales were $2,779 for the 2 styles, with A selling for $15.95 per shirt and B selling for $22.95 per shirt. In July, that's your second equation, total sales for the 2 styles were $2,385.10, with A selling at the same price and B selling at a discount of 22% off the June price. This is a toughie. How many t-shirts of each style were sold in June and July combined? So we have to figure out what x and y equals. So we're going to let x equal the number of style A shirts sold. We're going to let y equal Number of style B shirts sold. Okay, got to know what we're talking about. Once we know that, we're going to set up our equations. So we have an equation for June, and we'll have an equation for July. So let's look at the June equation. The June equation, we know the price for shirts was $15.95 times the number of the style A shirts plus, how much was it for style B shirts? $22.95, $22.95. I'll put the dollar sign in front of that. $22.95 times the number of Y shirts, style B, equals, total sales were $2,700, I'll put the dollar sign, $2,779. Okay? There's your June equation. July equation says the style A shirt sold for the same price times the number of shirts plus what is going to be the price for the style B shirts for July. Well, it's 22% off. So if I were going to do 22% off of a number, write it over here, 22%, oh, that's a bad 2. 22%, how do you change that to a decimal? Exactly, you move your decimal 2 places to the left. So 0.22 is going to be multiplied by the original price of $22.95, 9.5, and you're going to multiply the 2. I'm going to get rid of the 22% number and not clog it up too much. So 22.25 or 95 times 0.22 will give you a number. That number is going to be the discount. Okay? You're not done yet. You got to take the discount and subtract it from $22.95 to get the new price. If you go to the store and it was originally $22.95, you get a discount. You're not going to pay the discount amount. You're going to pay the price minus the discount. So you're going to figure out what that should be. It's going to be something. Y equals, what's the total sales for that July month? $2,385.10. So then you have your system of equations. You'll have the 2 systems that you'll have to solve using the elimination method. Okay, and then number 16 I did with you guys already. So you'll have that answer, and then you'll have to do number 17, I believe. Let me pull that page up. That was page 250. I do want you to do the hot problems. So 16 we did together. Go back and rewind the video or review it if you need to. 17 I'd like you to do because this is a common error that students make. So I'd like you to kind of be aware of it. So go ahead and take a look at that one and do the hot problem. I did 16 already for you, so do that one just on your book. And so your homework then is going to be will be to finish page 248. That's your guided practice. I didn't do all the problems because this video would have gotten way too long. Then you're going to do page 249. I gave you hints. Use the hints. And then page 250, including the hot problems. Okay, and I did one of the hot problems for you, so it's really only one hot problem. So this is your homework. Hang in there. After this unit, we will be in geometry, and it's going to be a whole different thing than what we've been doing. So I hope that you have a very good day, and I will see you next time. Goodbye.